All right, I just built this recipe agent SaaS prototype and I'm open sourcing it for anyone to use it, remix it, learn from it, launch their own SaaS with, whatever. It's got full AI workflows, tool calls, agent memory, full stack type safety, auth across the entire app and the agent, payments, AWS S3 file upload, and all the other small things that you would need to launch a SaaS to production. So that's the majority of the work. I'd guess to say about at least 80% of the work done already. And yeah, I was able to get this far thanks to building this on top of Mastra AI, an AI agent framework, and OpenSaaS, which is a SaaS template I created for React, Node.js, and Prisma, powered by the Wasp framework. It's actually one of the top SaaS templates on GitHub with over 12,000 stars now, which is really cool. And in this video, I'm just going to run through how this app leverages these tools to make a feature-rich agent that isn't just a chat app. So you're able to chat with the agent here like you would expect, but then when you plan and generate recipes, you get them dynamically generated over here with image generation as well. And you don't have to see and look through all the text in the chat view. And you can also save them to your database, favorite them, and the agent has access to these recipes to help you with your preferences and all sorts of other stuff that we'll talk about that deals with agent memory. So yeah, I'm going to dissect the most important features of building this SaaS on top of these AI workflows, like the agent memory, how to create and define these workflows in a structured and a clean way, how to define tool calls, and how to create this unique UI that responds dynamically to the agent results. So yeah, let's get into it. All right, let's just do a little rundown, a demo of how the app works. Let's start with asking the agent to find recipes from my collection that contain carrots. And you'll see that things for a little while, and you saw a little popped up there that it was doing a search, and it found 6 recipes. Okay, I've got some duplicates in here from when I was testing these stews and soups, but you see that it, instead of putting all the information here, and maybe what another chatbot or agent app might do is list out all your recipes, and then you'd have this big block of text listing all the recipes and ingredients that you have to scan through. Where here we've got it nicely displayed and filtered on the side here, and we can look through and hide and show the chat window like that. And we have just something that's a little bit more interesting for the user and something that's a bit more pleasant for them to use. And this is the kind of stuff you can do with these agent frameworks so easily because you're taking advantage of different forms of memory that the agent has access to, as well as these workflows that you create and these different tool calls. And you have access to a working memory, which is always something like an always-on memory. So it's like every time you're asking the agent to do something, you're telling them, oh yeah, by the way, this is what I like, this is what I don't like, these are the kind of recipes that I'd prefer, like fast, simple recipes for families, or you like to do French stuff, or you like, Latin American cuisine. And it's passing that every time in the working memory into context. Then you've got like session memory, which is your recent chat session storage. So it will automatically send the recent messages that you've passed back and forth with the agent into the context as well. And you can define how many or how little of that, but that happens automatically out of the box for you. Once you set it up, simply define it in a few lines of code. And then you have vector storage, which is the retrieval augmented generation. So you can access stuff based on similarity search from way in the past in different sessions, across different chat sessions. And this gives a lot of power to your agent. And because we defined these cool workflows, we can also do things like, let's say, I need a recipe for a bunch of kids for Halloween. And again, it's going to have that working memory in context. So it'll pass this stuff into me, and it's telling me, here are some recipes that it generated, and like, here's a fun one, mummy hot dogs or whatever. So brainstorm 3 more ideas. So it knows what I've already made. It knows what I like. And here it's going ghostly banana pops, spider web dip. Let's say, okay, we like that spider web dip. Generate a recipe for spider web dip. And now it's going to process this workflow. And here you can see that because we've defined this workflow so nicely, we can parse the actions and the steps it's taking and show those instead of streaming text. So now we're going to generate and elaborate on this recipe ingredients so that we get, something like this. That's a little bit more in depth. And it's going to generate the recipe images for us. So we have, something nice to look at, some nice basis for our kind of like recipe book here. And that's just like a cool example of what you can do with these agent workflows. We're taking multiple steps and you're combining them into one workflow as a tool that the agent can call. And in the end, once this recipe image is done generating, it'll save it all to our Postgres database for us and give us access to it. And this takes a little while because I'm using the GPT-1 image generation from OpenAI rather than faster and less high quality model. So there's a little patience here, but once this is done, then we can continue. And you'll see that it'll automatically refetch. And yeah, there you go. There's the spiderweb dip. We've got it. We can take a look at it. Cool. There's a nice picture. So we have an idea of how to present it. We can hide the chat window here, and we can look at all the ingredients and the instructions. So that's really cool. That's basically the app in a nutshell. So why don't we go over to look at the code? All right, so here is moving over to the code. We're in the master folder, in the agents folder, and this is how Mastra AI as a framework works, where you define some agents as your main, your first point of contact from the user to the AI. So here's a new agent, as we've defined here, with a set of instructions, which is basically your system prompt. I'm going to skip over that right now because you kind of get the idea of how that works. We just showed it in the demo. What I want to focus on real quick is this section here, which is what I talked about earlier in the demo, which is this idea of memory, right? So, all this information has to get stored somewhere that the chat sessions that the user is having with the agent. So in a general sense, we can just define storage, and a very simple form of storage is an SQLite store, which is just a file. And this is great for testing things out. And that's basically your recent memory, your kind of shorter term memory of the recent messages that you've been having back and forth with the agent. And what Mastra does that's really cool is it sets all that stuff up for you, and then it has this option here where you can choose how many of the recent messages to pass in each time with your new message. And so you don't have to do that. In other frameworks or with other libraries, you always have to save or store somewhere these recent messages and pass them into the context each time with each new message so that the agent has a bit of a reference of what you're talking about. So if you were to say like, oh yeah, I want you to brainstorm 3 recipes, it gives you an answer back with 3 ideas. Then you say, oh yeah, I like the 3rd one. It won't know what you're talking about unless you have some form of memory. And this does all that for you, setting up the database, connecting to it, retrieving recent messages and passing them into context, which I really, really liked. That was my favorite thing about working with Mastra. The other favorite thing was this idea of working memory, which is just kind of like the way if you use cursor and you have rules, and the rules are passed in each time so that the cursor's agent knows how you specifically want your code to be formatted, for example. This is the same thing where you have a template. So for example, here's my working memory template where I outline, meal preferences, like the user's ingredient preferences, how easy or difficult they like their recipes to be, their style of food preferences, stuff like that. So all those get passed in and updated when the user mentions something like that. And we can take a look at that real quick by just going to the agent and saying, what's the status of your working memory? And then we'll see that template all filled out here, right? So because I asked it in past sessions about, what are some recipes? What are my recipes with eggs? It added that there. Halloween recipe as ideas. You just saw that. It added that. Additional notes. I like pizza, oven recipes. That's really cool. A really cool aspect of Mastra and its memory. And then finally, you have semantic recall, which is vector storage or retrieval augmented generation, RAG as it's called. And that does a vector search and finds from anywhere in the database similar topics and includes those in the context. You can read more about that. It's a little bit more complicated than that, but we also pass here to create a vector database. We need to embed all of these chat sessions, vectorize them to store them in this vector database. And OpenAI has an embeddings model, and all we have to do is one line of code, and we get that without having to chunk text, send it over to an embedding model, get the vectorized piece of text back, and store it in the database. So that's huge as well. That's really, really cool. That saves you tons of time and brings a lot of functionality to an agent right away. And another thing is, you'll see here, we pass these tools and these workflows that we create to the agent. And the agent knows then that it can call these workflows or these tools and parse this information, this result that it gets back, and communicate that back to you. So why don't we take a quick look at the most important workflow, which is the generate complete recipes. So you saw we got some recipe ideas, and then I said, yeah, I want you to generate that for my collection so that it saves to the database. So the way Mastra does it, which is really nice, is it creates steps. And the cool thing is that you have input and output schemas that you define within Zod, so that from the initial point, between, and then as these results get passed out of one step and onto the next one, everything is type safe. And so you'll know where issues arise early and where some things might not be fitting into the schema. So here we have an input schema and an output schema defined for this step. So that is this one here. And it's just an array of titles. So by defining that, when the agent here, our recipe orchestrator, when I tell it that I want to create or generate a detailed recipe, it's going to automatically pass an array of recipe titles to our workflow. So that's really cool. There's a lot of stuff there going on under the hood that we don't need to worry about. And then I tell it to access this other agent, the recipe elaborator, which basically is just saying, take this, generate this recipe with all these ingredients and such. And I tell it that I want a structured output. So our elaborated recipe schema looks like this. It's an object with a title, ingredients, an array of ingredients, an array of instructions, and a thumbnail URL. So it's going to generate that, and it's going to pass that to the next step, which is generate the thumbnails step. So for all the recipes that may be generated, maybe 1, maybe 5, it's going to generate a thumbnail for this recipe, which is a tool that we created here. And it's just basically calling OpenAI image generate GPT-1, and we pass it the recipe title and the recipe ingredients, and it's going to generate an image for us. It'll pass that back, and then we will return that, and we'll send that to the next step. And so, of course, the output schema needs to match the input schema of the next step, which is save recipes to the database. And because we are using Wasp as our framework, Wasp has this really cool thing called operations, where you just define, I'll show you here. Wasp knows about your whole app from front end to back end. And because of that, you can define in a file like this, a save recipes action, which is right here. And it looks like that. Pretty simple. It's also fully type safe from front end to back end. And this is how you set up a server action in Wasp. It's also that simple. You get access to the arguments and the context because we've typed it. It knows it's going to get this elaborated recipe type, which we've generated from the Zod type that we use in Mastra. And then we just say, hey, save all these recipes to the database that you get. And that's really cool because Mastra then has access to that calls save recipes, really easy. Boom, it's in your Postgres database. And then finally, all we do is to define the workflow. We use Mastra's create workflow method here. We show it that we want it to run all three of these steps, the generate elaborated recipe step, the thumbnail step, and then save to the database, commit, and that's what we are passing over to our recipe orchestrator so it knows to call that. So that's a really cool, type-safe, very encapsulated way of generating more complex workflows that get called from an LLM, which I really like. Okay, so how do we actually communicate with this agent that we just created along with its workflows and tools and all that other stuff? How do we get those streaming messages back from the agent on our client? So when we ask it something like brainstorm more recipe ideas, how is it sending us this information and this streaming text back? All that good stuff. So you saw how we created the agent, but we need a way to communicate with it. And the answer here is very easily in Wasp with a Wasp API. So here we have an API function that we have typed, and it gets request, response, and context. These are all typed arguments thanks to Wasp, because we've defined this API function in our Wasp config file here. We have the stream chat with recipe agent API. Here is the route that it will be accessible on as a post request. We'll have access to, through the context object, we'll have access to the recipe entities or those database models via Prisma. And we just reference then this function that we created. And the cool thing is that by adding auth is true, then we get an authenticated API endpoint out of the box via Wasp. So that's really cool. So there we go. We set the headers as chunked, and right away we can check the context object for the authenticated user. And if not, we can throw a not authorized error. And that makes things very easy for us, because as well, we can use the Mastra client call get agent with the recipe orchestrator ID to get that agent that we created that has access to everything. And then we stream the result back. And the important thing to note here is that to get access to all that memory that we configured in the Mastra agent, we have to pass a resource ID and a thread ID. And the resource ID should be something like your user ID so that we can separate it by user, by logged in user. And the thread ID can be your conversation or chat session ID, so chat 1, chat 2. And that way we save everything to memory correctly, and we can access it from memory correctly as well. And the stream result that we get back, we want to access the full stream. And what's happening is chunks are being sent, and those chunks have different types on them depending on what is being processed in that moment. So if it's just a piece of text, like if you just add it, send me some recipe ideas, it'll send you back text delta chunks. And those, we can just handle them very simply. We can send those to the client, and the client can show each new text chunk, add each new text chunk on, concatenate it onto the previous message, and that's how we get that stream flow. Or we can process these different tool calls, like this tool call input streaming start. Then we know that this tool call is starting, and if it's the right kind of tool call, for example, if it is the step in our workflow, we don't want to send or show the text chunks, the text delta chunks. We want to tell the user, hey, recipe is being generated now, the text is being generated, or next, the recipe image is being generated. We can do all that through these tool chunk types, and we can handle them differently. The same with the result. When we get the result, if it's a certain tool result, then we can decide, okay, let's stop all the processing here. Let's end the streaming response from the server and not send any more text chunks back. And then we can just, inform the user, hey, your recipe is generated, and then boom, it pops up on the client. So we can look into these chunk handlers, and you see we're just writing these objects as JSON strings to the client, and the text chunks are very simple. They just have content, and the tool call chunks have a status, like starting, and they send different content back, like starting recipe generation or starting recipe search, depending on which tool is being called. And that's pretty much it. Then on the front end, we created this use text stream hook. We do something similar where we call that text stream and we set the response based on whatever tool chunk type we're getting. And if we're getting any of those tool calls, tool output, tool result, we handle it this way where we just replace the previous message with the current one that's coming in. So we might change the tool call status from starting to finished, and that's a signal to the front end to stop the flashing animation. And an important thing here is the chunk, the text chunk that's being sent is always replaced. So when we get a new one, we replace the old one. So that's make sure that the text in place coming from the agent gets replaced and not added on, so that we don't see recipe generation starting, and then it says also plus recipe thumbnails, images being generated. No, we replace that message. And if, for example, the chunk type, the tool result is sending back a string of recipe IDs, then we can inform the front end and we can filter on our little sidebar there. We can filter to only show the certain IDs we got. And that's how we do it. Just simply setting a state object in React and updating the client accordingly. And for the text delta chunks, instead of replacing the previous chunk with the new one, we concatenate it, we add it on, and that's how we get that streaming result that comes in. And there's more to it than that, but at the core, that's all it really is. And it's super simple because of how the frameworks both work, in the sense that you can just define this agent and access it, call it super easily by sending in the message input from the request body. And defining this API endpoint is also super easy. Authenticating it was very, very easy because of Wasp. And just to show how Fullstack Auth works in Wasp as to kind of tidy up the whole example, you can see here it's defined in the Wasp config file as an auth object with many different type of methods. You can do Google Auth, you can do GitHub Auth, or you can do verified email. And by doing that, it's you sign up with an email, you get a verification code, you click it, and then you can log in with that email. And that all of that full stack authentication for verified email login is done in this 12 lines of code, 20 lines of code here. So super simple. Full stack makes creating the external API endpoint and authenticating it easily. And that's how we're able to communicate with this agent and its tools and workflow that we generated. All right, so that's going to wrap up this walkthrough. And remember, all this code is open source. It's free for you to use, remix, launch as the SaaS as is, whatever you want to do. And it's got a ton more than that. It's got an admin dashboard. It's got analytics. It's got it's using ShadCN components, file upload. It's got its own landing page with nice pre-built components for you. It's got all of the agent work and agent workflows in the master folder, payments with Stripe, a bunch more. So it's really a full-featured code base. And like I said, it's built on top of OpenSaaS, and OpenSaaS has over 12,500 stars, and lots of people launching SaaSes and startups using it. So check it out and have fun.